Okay, for this lesson we're going to look at practical applications for quadratic functions, basically problem solving with quadratic functions. So, we're told during a high school football game, the height of a punt can be modeled as a quadratic function of time where h is a function of t is equal to -5 bracket t minus 1.5 squared plus 12.25. In this case, they're stating that t is the number of seconds which have elapsed since the football was punted, and h is a function of t is the number of meters above ground after t seconds. So I'm going to label that right now. I'm going to say that this axis is going to be t, this axis is going to be h, and that this is representing time in seconds, and this is representing height in terms of meters. Now, if we are trying to, without the graphing features on a calculator, explain how we can determine determine the following from the equation and actually state the values. Well, when it says the maximum height of the football, the maximum, as we've already seen, because this is in vertex form, the maximum is the y-coordinate at the vertex. Or the k value. In this case, we can see that the k value is represented by 12.25, which means that the max height is 12.25 meters. The time it takes for the football to reach its maximum height, well, the time is going to be represented by the x-coordinate at the vertex. In this case, it's the h value, which we can see inside of here. If h is equal to 1.5, then we can say it takes 1.5 seconds. If we want the height of the football above the ground as the punter makes contact with it, then we're looking for the y-intercept. Or the height at 0 seconds. So then I would say that the height at 0 seconds is going to equal -5 times 0 minus 1.5 squared plus 12.25, or 1. The football starts 1 meter above the ground. Much like with the last question, the height of the football above ground 0.5 seconds after contact is going to be when I replace the t value with 0.5. And I would say that it would be negative 5 times 0.5 minus 1.5 squared plus 12.25 or 7.25. The height of the football is 7.25 meters above ground. Zero 0.5 seconds after contact. When I use the graphing features on my calculator, then I'm going to graph it out, and I'm just going to need to change my window settings so that I can see the y-intercept. I can see the vertex. And I'm going to solve for the x-intercept as well. So I know the y-intercept, which we've already solved, is at 0 and 1. I know the vertex from my equation is going to be 1.5 and 12.25. And when I use the zeros function or the roots function in my calculator, I can find that the x-intercept is going to be 3.07 and 0. If I want to determine after how many seconds to the nearest tenth the football is 10 meters above the ground, then I'm going to put in a second equation where y is equal to 10. And then I'm going to solve for the points where these two equations intersect. And I discover that these intersect at 0.8 and 10, as well as at 2.2 and 10. So I can say that this occurs 0.8 and 2.2 seconds. The punt is not caught by the opposing team and the football hits the ground. Use the features on the graphing calculator to determine how many seconds to the nearest hundredth it took for the football to hit the ground. That's when I solve for the x-intercept. It took 3.07 seconds for the football to hit the ground.